Hello everyone and welcome to the second video on the systematic approach to EDA. So in this video, I will be talking about the first four steps that I had discussed in the last video. So basically, I will be talking about the first part of this notebook. Okay, so let's get started. So basically, the first and the second step talk about finding out how many rows and columns are there in a data set, and then finding out the summary statistics, the appropriate summarization of numeric and categorical data columns. So for this particular exercise, if you see, I'm importing two modules, two libraries out in Python. One is pandas. We often import pandas as PD, that is acronym or short form for the library pandas, and we import another library which is a scientific library called NumPy. We import it as NP. NumPy has quite a bit mathematical functions in it, and it will be quite handy as we go about exploring data. So this is the URL from which I'm reading the Titanic dataset. We had done this in the previous notebook as well. I'm reading it using the pd.read_csv command into a file name called Titanic. So the data frame is going to be called Titanic. And just to get a quick sense of what is in the file, I'm doing a dot head. So a dot head command, basically that function tells you, shows you the first 5 observations in the data frame. Okay, so by now we know the data frame quite well. This is a data frame of passengers. The survived columns tell you whether a person survived the catastrophe or not, and the sex or the gender of the person, the age of a person, and the class of travel of a passenger. Now, for step 1 and 2, you can use what we had learned in the previous file, basically. So essentially you will use the dot describe command for numeric columns, and you can use the value counts for non-numeric data columns such as passenger class. Okay, and also for the sex column. Okay, you could also use unique and n unique function as well. And now what I have done is I have done a titanic.count function to see if there are any missing values. So you know that basically there are 1309 records in the data set. But if you look at age, okay, if you look at age, you will see that the count for age is 1046, which essentially means that age has missing values. So you know how to do the missing replacement using fill and a function, and you can also take a look at the number of missing values by using isNull.sum, which will give you specifically the number of missing observations for age, and for all other columns there is 0 missing information. Okay, so this is again a revision on what we had done in dealing with missing value video. So basically you can use fill NA, and you can fill the missing values of age with the mean of age. Okay, so you can, this is something that we have already done. So let's talk about step 3 and 4. So step 3 is looking at the distributions of numeric columns using histogram and box plots, and then looking at the bar charts for categorical data. So here I want to introduce a new library in Python, which is known as Seaborn. So we will import Seaborn as SNS, and we will import matplotlib as .pyplot as PLT. And when we say percentage matplotlib inline, basically whenever you're trying to create a visualization, it shows up in the line, or in other words, in the notebook that you are using as well, instead of creating a separate pop-up window to do that. So that is why we're saying matplotlib inline. Okay, so now this is one function which you can explore. So essentially sns.distplot, and this dist plot is essentially a distribution plot. And as you see, when I said dist plot, and inside that I gave the column which is age, and I got a distribution plot for age. Okay, now there are a few things which you can do here. So if I execute this function as is, you see that there is a smooth distribution plot which is drawn over it as well. This is also known as the kernel density estimation plot. And if you want to switch that off, you can easily say KDE is equal to false. And now you see that the distribution plot is gone. And another thing that I want to show you over here is that you can do Shift Tab to take a look at the detailed properties of a particular function or API that you are using. So this is something which you can explore on your own. And just to show you how I brought that up is basically you go to the function that you're working with. In this case, this is distplot, and I just have to say Shift Tab. When I say Shift Tab, I can see the details of the distribution plot or the distplot function in Seaborn that we are interested in exploring. Okay. Now, similarly, there is another plot which is called the KDE plot, which can also be used to look at the univariate distribution of a numeric column. Now let's take a look at another plot, which is the box plot. We had talked about box plot earlier on as well. Box plot can also help you know the distribution of numeric data. And in this case, I'm using sns.boxplot to create a box plot for age column. And you see that one of the functionality is that if I said y is equal to the name of the column, I got a vertical plot. But if I was to change this y into x, you see that I get a horizontal plot. So these are basic things you can explore again by doing Shift Tab and looking at the detailed properties of a box plot. So far we have looked at how to create histograms and box plots to analyze the distribution of numeric data. In the next visualization, I want to show you how to create a bar chart for categorical data to analyze the distribution of the categories within a categorical column. Now here you see that survived is one of the categorical columns in the data set that we have, and the function from Seaborn is count plot. So if I say sns.countplot and I give the name of the column, then I get a bar chart which shows us the distribution. So you can see that a smaller percentage is yes. So obviously a fewer percentage of people survived than the ones who did not survive. So this is basically our step number 3 when we are getting to know the distributions of the columns in our data. And now for step 4 in our list, which is to look at the relationship between numeric variables, you can do a few things. So one is this dot core function. So what is the dot core function? The dot core function is basically a correlation functionality. So in this Titanic data set, we only have one numeric column, and hence dot core did not give a very good output because age is the only numeric column here. But you can try this out on the property data set, which we have given you for a do-it-yourself exercise. Okay, and if you want to visualize the correlation, then essentially you can use this command. You can do a heat map, and inside sns.heatmap you can basically give this correlation function, and this will give you a heat map. So try this out on the property data set. The other bivariate plots which you can try in your on the property data set are joint plot and pair plot. And later there are questions in the property file, in the property DIY exercise, where you have to create a joint plot and a pair plot for your practice. Okay, so I will end this video here, and in the next video, we will go over steps 5 and 6 of an EDA exercise.